Hey, hi everyone. This is Vivek. I'm AWS Machine Learning Hero and I'm lead of AWS User Group Madurai. And today we have two wonderful speakers, who's Zach from ANZ and we have Abhishek from Mumbai. And we are going to talk a lot about containers today. All right. So for people who are already much familiar with what we do, so welcome back. And for folks who are joining for the first time, let me give a bit of what we do and who we are. So AWS User Group Madurai was started in early 2022, and we started. This is the third user group that exists in the state of Tamil Nadu in India, and typically that's like more than lots of user groups in a single region. But we operate quite very differently. So we are more focused towards regional learning and development, and then we have run so many initiatives for students, professionals, developers, and startups so that we could empower this ecosystem that we are trying to build. So over this past 3 years, we have wonderful folks, speakers, and organizers and volunteers supporting us. And one such is what is Lokesh, who has been like one of the first members of User Group Madurai, and right now he is a co-organizer of User Group Madurai as well. So, with that all being said, today we are running wonderful initiative. This is the, if I'm not right, if I'm not wrong, I think it's the 7th or 8th month of an initiative called Build a Sprint Initiative. So the main reason why we went to start this initiative is that we wanted to give not just the learning sessions, but also to build something along with what we learned. And that is a unique aspect of this sessions that we are running in user group Madurai. And for this month, we have chosen container as our theme, and we have two wonderful expert speakers. We have Zach, who is AWS hero from ANZ, and we have Abhishek, who is AWS User Group Nasik lead and AWS community builder, who's going to talk about containers and lots of other stuff. I'm here to, I'm not an expert in containers, so I'm going to sit down and enjoy the show and learn a lot on a Saturday morning. I hope so you're also for the same. And over to you, Lokesh.
Thank you. That's a great info. Yeah. Good morning, everyone. Welcome to AWS Build Up Skill Sprint. This is a container month. Like we are like many sessions over last few months, like Chennai, serverless, and so on. Like today, we are just diving into one of the most important topic in the modern teams, like moving from easy to basic deployments into world of containers. Everyone knows like we are two incredible speakers with us UG leaders from the AWS community, an expert who solved the container challenge at large scale. At first, we are like Abhishek Wang. Abhishek is a senior platform engineer at Quantify and also AWS user group leader at NOSAC and also a community builder. He has lots of hands-on experience with helping organizations to adapt with the containerization architectures in the right way. Today, Abhishek will guide us through how to choose the right AWS container services from ECS, EKS, or AppRunner. If you ever wondered which one fits your team, your workload, or your scaling needs, Abhishek will give you clarity whichever you need. Next, we have Asad Zakaria. He is a senior engineer at Zero and also AWS Hero and also a AWS user group leader in Wellington. And also he works deeply with Kubernetes and large-scale cloud platform. This session takes us through the EKS Auto Mode and also building custom node poles and node classes. We'll unpack how like powerful automations can remove the Kubernetes operating overloads, give you whole control and efficiency and flexibility to tailor the clusters for your workloads. Together, the session will help you to choose the right container platform and like how to run efficiency automatically in large scale. Yeah, welcome you, Abhishek and Jack.
You want to have a say a quick hi to the audience?
Sure. Hi, everyone. This is Abhishek. Thanks, Vivek, and thanks, Logesh, for having me today. It's a pleasure to present at the skill sprint which you guys are having. I've been following this initiative since long, and it's a really good way to touch upon all the aspects like we have serverless containers, then we have AI/ML, a lot of stuff. So it's good to be able to learn from all the experts. And again, it's a pleasure to be here. And I'm sure we'll have a good learning session today. So looking forward. Thank you so much.
Thanks, Abhishek. Vanakkam, Madurai. I think Kalai Vandanangal. So I'm Zach, Arshad Zakaria. I think Vivek has already gave some introduction about myself. Yeah, let's learn about EKS Auto Mode and some of the problems we have, like with the node classes, node tools, and there are some surprises too. So hopefully the demo goes with me today. So let's get started.
Awesome. Great.
Yeah.
Cool. So I think we can start. Again, before starting, thanks everyone. Thanks Madurai user group and those who are tuning in on a Saturday morning. Thank you so much for being there on the live stream, and those who will be seeing this session afterwards in the recorded form. Thank you to them as well. Okay, let's dive in. Today, actually, we are diving into choosing the right container service on AWS, because everybody knows containers is a one of the most important topics in AWS, in DevOps. If you are a DevOps engineer, if you are managing infrastructure for your teams, container skills are something that are must have nowadays, and AWS is a leading choice by all of the major players in the industry to be able to host containers and run their applications on. So basically, AWS offers multiple ways to run containers, and people often feel confused about, okay, AWS has a lot of services, and what are the differences between them? How should I choose it? Is there any framework using which we can basically choose a useful and most suitable use case for our workloads? So we are going to talk about a lot of that, and my goal is to make it simple for you. It's going to be a lot of theoretical session, but I think it is really important, since it's a beginner friendly session. It's really important to understand the basic concepts. What are the fundamental differences between multiple services which AWS has to provide? So we'll dive in, and before that, I will quickly show, and quickly explain what actually containerization means. Then there are some prerequisites to know before we dive into actual AWS services. So yeah, let's move ahead. So basically, containers. So whenever you hear containerization or containers, what comes to your mind, right? So for me, it is something like an isolated environment, an isolated room sort of a structure where you can, store things, right? As a simple method. But so similarly, containerization concept is nothing but having containers with your application code and package dependencies in an isolated environment, which is running on a machine or on a server, or on your local laptops, whatever server dependencies you have, and you can run that isolated in an isolated way, and maintain the consistency. So basically, when we define containers, what we do is, for example, let's assume an example where you are building an hello world application, right? So when you build that application, and let's say you try to run it on your machine, right? It runs perfectly fine. Now let's say if you want to share this with your friends, or if you want to share this on internet, and there are some dependencies which the users to whom, or your friend on his machine, does not have those dependencies, right? So there is a high possibility that he might say that the application is not working on my machine, but it runs perfectly fine on your machine, right? So it's a classic problem of, right, it works on my machine, right? So many of you might have already heard some things work on our machines perfectly fine, but if you share it externally, they tend to fail, right? So containerization solves that basic problem, where you package your application in such a way, right, with along with your dependencies, and all the required things, and it will run in an isolated environment with underlying infrastructure you have, and it will perform uh, exactly same as it used to run on the machine of you, or like the person who has shared that particular application with you. So that is it. Like basically, containers are lightweight, portable environments that package your applications, their dependencies, all the required configurations, environment variables, and they ensure that your application stays consistent throughout your computing environments, be it your local laptop machine or be it your EC2 instance, it's a remote on-prem server, whatever you want to run your container on. So it basically simplifies the deployment, it enhances your scalability of your application, it reduces the operational overhead of maintaining a lot of things on different operating systems. So a lot of these things are eliminated when you try to use the containerization ecosystem. So yep. And now moving ahead, why do you want to choose containers, right? As I already mentioned, containers solve the classic problem where someone says it works on my machine, but problem might be in your machine that it is not running, right? But actually it's not the case. So you package your application once, you can run it anywhere, as I mentioned in the last slide. So it gives you faster deployments. It is again lightweight. If you have already learned about microservices which runs in a distributed fashion, so it is a very good use case to use containers in your microservice ecosystem, since it gives you the consistent environments and portable application. It is great to maintain CI/CD as well, because you have only one container ecosystem to manage. The moment you apply all configurations to that container ecosystem, all your changes or wherever your application will run will copy exactly the same configurations. So this is why nearly every modern cloud workloads today start with the containers, and everybody wants to use container ecosystem while maybe they are building a startup or simple deployment of a web application. Everybody is interested to use the containers because of these flexibilities containers provide, right? Now coming to a part where now we learned about what container is, right? And why do we want to choose the containers? But now what are the different ways using which we can build the containers? Now you understand what container is. Now you want to build your container, right? So so there is you might have already heard about Docker. So let's understand the Docker first. So basically, before we talk about running containers on AWS, we have to have this knowledge of Docker and Kubernetes fundamentally, so that you are able to first build your application. Then we can use AWS container landscape to utilize the scalability and all the managed benefits of that. So Docker is the most popular tool for creating and running containers. It allows developers to package an application with everything it needs, be it libraries, Node.js libraries, Python libraries, whatever language framework you are using, all the dependencies, their runtime, operating system needs, right? Each application has different operating system needs. So those everything Docker helps to package in such a way that it can be shareable, right? So, and what Docker does is basically it builds all the dependencies, libraries, everything into a thing called as image, right? So image is nothing but a blueprint of an application. Now let's say you have an application, might be an hello world application, and you want to share that with your friend. You cannot share the exact code of that, right? Of course you can share, but it is not a good way to share, right? So either what you can do is you can build your application code in a Docker image and share that image with your friend, and that will be an isolated structure which your friend or anybody on the internet can be able to download on their machines or download on their servers and run it independently, right? So from that image you can run containers in a very lightweight fashion, isolated environments, as I already mentioned, and you can start that instantly. So there is no need to beforehand install your dependencies because the image already has it, right? So it's not like if you get that Docker image and you'll again have to install everything, all the dependencies. So there is no need. Once it is built in Docker image, it's a blueprint, it has everything, and you just have to run the Docker image and you'll have your application up and running within minutes. So basically, on a very high level, Docker is a platform, open source platform to build, package, and run applications in a containerized form. And it ensures apps run the same everywhere, be it your laptop, your server, your cloud environment, or your on-prem systems. So Docker basically, as I already mentioned, uses images, which is nothing but a blueprint. So whenever I use a term in throughout this session called as image, so just assume in your mind that image is nothing but a blueprint using which we can run application on any machine. And basically it is again lightweight, fast, isolated. These words you'll hear a lot throughout the session. And it is again ideal for microservice, as I already mentioned, because distributed systems are something which needs lower operational overhead, and Docker and containerization give you that operational or lessens your application overhead which you have. So now that we know Docker, let's move on to a super class of it. Maybe you already know about it. It's called as Kubernetes. Okay, so Kubernetes is also called as K8s. You might have heard a lot of times in on the internet. If someone already uses Kubernetes, then they already know how useful it is. But it comes with a cost, which is nothing but you have to maintain a lot of things there. So there is a lot of operational overhead involved. So basically, to understand Kubernetes on a very high level, Kubernetes is a container orchestration system. Okay. Now in last slide we saw we have something called as Docker, which helps us to run containers, build images, right? But as a single form. So you cannot orchestrate or have multiple containers using Docker and manage their ingress, manage the traffic, manage the observability as a single platform. So if you have a workload that is in a big scale, or if you want to run thousands of containers, you won't be able to manage it effectively using Docker only, right? You can definitely run hundreds and thousands of containers using Docker, but it is not scalable when you have a lot of scale in your machines. So Kubernetes helps here to orchestrate all those containers, be it in any numbers, hundreds and thousands. So you can manage the container deployments, their scaling, networking part. If they fail for some reason, then replacing the container. So a lot of these things are managed by Kubernetes, and it again reduces the operational overhead. It reduces the fatigue on the platform teams throughout the project to maintain the applications properly. So again, as I mentioned, it is ideal for large scale microservices architecture, where you have lot of systems running, like such as thousands of applications, replicas are running because you have a lot of traffic. Then in that case, Kubernetes is the way to go for you or your project or your team. It again supports multi-cloud and hybrid setups. So for example, you say you do not want to use any of the cloud provider because you have some sort of a policies in your company where you want to use your on-prem systems. Kubernetes can be run on any of the systems, and it supports hybrid setups as well. Since it is open source, you can run it very flexible way in any of the machine in cloud. And if you want to relate how Kubernetes can be run into AWS in AWS managed ecosystem, then it is called as EKS, Elastic Kubernetes Service. It is an AWS managed Kubernetes service, which of course we are gonna see in the further slides. So now that we have understanding of what container is, why do we want to use containers, then what can help you to build the containers, which is nothing but Docker, and how to orchestrate on a large scale all those containers for which you can use Kubernetes. So these basic fundamentals, now that we have covered, we can definitely move to the container landscape of AWS, right? So in this session, I've chosen 3 services. There are multiple more ways also, but these 3 which you are seeing on your screen are the major AWS services which people are using right now in their production environments to use containerized application. So first service we are going to talk about is Amazon ECS, Elastic Container Service. Then secondly, Amazon EKS, Elastic Kubernetes Service. And the third one is AWS App Runner. Okay, so this is the full suite of container services which AWS provides, and we'll focus on these 3 services. So yeah, without further ado, let's dive into the ECS first. So basically, ECS is AWS's homegrown orchestrator, right? So so let's assume we have discussed about Docker, and Docker helps you run your application in a container, in a single container or multiple containers. So similarly, Amazon ECS is fully managed container service from AWS, where you do not have to manage the scale or adding or scaling vertically, horizontally, right? So you can use ECS to orchestrate your services and simplify the deployments and scaling containerized applications, providing integrations with other AWS services. So in that way, if you want to use your application in a containerized form, ECS is a very beginner friendly service where you can host your applications from. Now, it is, since it is a fully managed container orchestrator, you do not have to select your machine's requirement. Like for example, even if your application sometimes need more memory, more CPUs, then let's say sometimes your traffic increases to your application, then you'll have to scale out your applications. You will have to have multiple instances of your application running the same environment. So those things are managed by ECS, where you can add auto scaling groups. If you have already know about EC2 and Fargate, you know that those have the capability of auto scaling groups, right? Auto scaling groups are nothing but in a simple way, they add a lot of instances when the traffic increases, and they remove the instances also when the traffic decreases or there is a lean patch of traffic. So which helps you reduce your cost as well, and save your compute environments. So basically, when you use ECS, those capabilities of auto scaling groups by EC2 or Fargate are they come hand in hand. So basically, ECS uses two major compute services by AWS. One is EC2 and one is Fargate. So if you want a more granular control on where your application should run, or what should be the configuration of your machine where your application is running, then you should definitely use EC2 as a ECS compute. And if you don't know about behavior or of your application's traffic, and you do not want to manage all those resource stuff which comes with EC2, then you can definitely use Fargate, because Fargate is a serverless service, serverless compute service. ECS can use it very effectively. The moment your application needs more resources, needs more traffic, then it can definitely scale on its own. So all of your operational overhead is reduced by ECS. ECS runs your application throughout its life cycle, and it scales up and scales down whenever it's needed, right? So it has deep AWS integration because it's AWS homegrown service. You can integrate ECS with multiple services such as code deploy. Then you can have EC2s, and you can have multiple launch types such as EC2 and Fargate. So this becomes easier when your other application dependencies or other services are deployed to Amazon's different services. So ECS is the service you can definitely use for that. And as I already mentioned, if you have a microservice architecture, you should definitely try ECS with Fargate, because it works beautifully with Fargate. So these are some easy pointers, just to summarize whatever discussion we had in the last slide. When should I use ECS, right? So first of all, if you want simplicity, if you do not want to manage a lot of things such as compute, memory, and you do not want to dive into a lot of hardware stuff, then definitely you can use ECS, because it abstracts all of that, and it takes care of all those aspects on its own. So AWS is responsible for scaling, managing all those infrastructure things on your behalf. Then you don't need Kubernetes, right? So as we discussed already, Kubernetes is not for everyone. So it's not like if you are running Kubernetes, if you are running containers, you need Kubernetes, is a myth. Kubernetes is only for when you have a lot of containers running at a single time, then you can definitely use Kubernetes. But if you are just starting out, if you want to just build some sort of an MVP for your startup, if you are just running a web application, then definitely you don't need Kubernetes. Then you can definitely use the ECS service. You prefer fewer moving parts. As I already mentioned, moving parts is nothing but a lot of instance management, then their observability management in different formats. So if you don't want all those things to manage, you can definitely use ECS. It has a centralized platform where you can take care of all those things. And again, as I already mentioned, if you want strong AWS native integrations with other AWS services which AWS has, then definitely you should go with the ECS. So to summarize, ECS is Elastic Container Service, where you provide your application image, application Docker image, and ECS will take care of running those applications on your behalf on either EC2 instances or Fargate instances. And rest all things are taken care by AWS and ECS. So this is what ECS about. Now let's dive into EKS. So as I already mentioned, EKS is Elastic Kubernetes Service. EKS is short form for that. So if your application definitely needs Kubernetes, so this is a service you want to use, right? So if your team is already using Kubernetes, let's say you are running on-prem, or if you are building your application which will have a lot of traffic, which will need a lot of compute resources and a lot of containers, then you already use Kubernetes, or if you might have already using Kubernetes on your local machine, but with native features, right? So if you want all that abstracted with more control on your side and full access to Kubernetes ecosystem, you can definitely use EKS. So it's a basically managed Kubernetes control plane where you do not have to manage the control plane. EKS, which is nothing but Amazon, takes care of managing Kubernetes control plane. You just have to mention what are your compute memory requirements for your applications, what will be the nodes that will be required, what is the scaling policy that will be required. All those things you need to define, and then all the rest of the things regarding managing your application, sharing observability, then maintaining the traffic, proxies, everything will be taken care of by Amazon. Now coming on to the add-ons. Now EKS comes with, as I already mentioned, EKS comes with some sort of an operational overhead where you'll have to manage your add-ons such as service mesh, ingress. Then there is operator. Ingress is nothing but managing the traffic which is coming to your application. Those who do not know. So for all those things, you'll have to have the add-ons by AWS. Again, since ECS also supports EC2 and Fargate for their compute for the nodes, EKS also supports both EC2 and Fargate. So if you want to use a serverless compute for your application workloads, you can definitely go to Fargate. Or if you want to have control in your hand in terms of where should your application run, what should be the memory, what should be the CPU, and all those things, then you can definitely choose EC2 where you'll have more granular control over that. So this is a high level on information about EKS. Then we'll talk about when should I use EKS. So basically, if you want to use Kubernetes features such as orchestration, then managing replica sets, maintaining deployments, then automatic scale up, scale downs, definitely then you can use EKS. But it comes with a cost. Cost is nothing but having an experienced platform team. Beginners will definitely find it a little bit hard to dive into Kubernetes right away if they don't have the basic fundamental idea of what Kubernetes is and how to run basic Kubernetes on their machines. Then they'll have a hard time finding it understanding the Kubernetes or EKS ecosystem. So you will need definitely an experienced platform teams, and you'll need a knowledge of Kubernetes underlying infrastructure. Then you'll be definitely able to use the EKS. Then you want full ecosystem flexibility and multi-cloud or hybrid nature. You can definitely run EKS on your on-prem servers also with a hybrid. So there is a service called as EKS Anywhere for that, where you can have your control plane in your AWS console, but you can run the actual containers and maintain them from the EKS control plane from your on-prem server. So that is also possible. It gives you that flexibility of multi-cloud and hybrid ecosystem. And sometimes when you need advanced patterns such as service mesh, operators, then you have custom resource definitions, Helm charts. So all those aspects, if you want to use, then you can definitely choose the EKS service, right? So this is all about EKS. So again, to summarize, EKS is Amazon's managed Kubernetes service, which if you are using Kubernetes for your application workloads, this service will give you a whole lot of other controls to manage your applications in a very better way, efficient, cost efficient ways. Now diving to the third service, which is called as AWS App Runner. So this is the most basic container service than ECS and EKS. Okay, so App Runner is for people who want a Heroku-like experience. So if you are a web developer, or if you are into application development, or in your early career, you already know Heroku and Vercel are easy deployment methods for your applications, web applications, right? So where you do not manage servers, you just share your requirements and share your code of application, and they take care, the platform of Heroku or Vercel takes care of your deployment and everything. So similarly, AWS App Runner builds and deploys your web applications automatically. Then it load balances the traffic so that your application does not break under a lot of traffic pressure, with encryption, with managed secrets of your application, and scales to meet your traffic needs. So you can consider it as, let's say you have a Docker image of your application built and you do not want to manage anything. So what you'll do, you'll go to App Runner console, you will simply provide the image which you have for your application, and App Runner will simply deploy it, right? So this is what App Runner is about. It is the simplest way to run containers. It auto builds. It can auto build from GitHub or ECR. So those who do not know ECR, so ECR is a container image registry for AWS. It manages all your application images, Docker images, and through which you can use different services such as ECS, EKS, and App Runner. Or it can also build from your GitHub. So let's say you have a code for your application, you are pushing that to GitHub or GitLab, and you want to build your application using App Runner from GitHub directly, then App Runner definitely can help. Then, as I mentioned, auto scaling and load balancing is very much possible with App Runner. It takes care of distributing the load of traffic to all the other instances so that your application runs smoother. And it can also check a lot of other aspects such as health check. If your application is up and running, does it have any issues? Is it failing? Then all the other logs, application logs, are visible through App Runner. And one major point of App Runner, which is an advantage, is nothing but zero infrastructure management. As I mentioned, you just have to provide your code from GitHub or Docker image from ECR, and App Runner is responsible for all of the infrastructure management, all of the server management, health checks, logs requirement, load balancing, traffic migration, or auto scaling. Everything is taken care by App Runner. So you just have to push your code or container, and App Runner does all the rest things. So we have already discussed, but these are the simple points and summary points. When should I use App Runner? If you want simplicity above everything, and you are running a web app, simple web app API, and you do not want to manage infrastructure, you do not want to manage servers, their memory issues, or spinning up their traffic proxies, etc. You can definitely use the App Runner. You are, as I mentioned, you are a startup or a small team, or even if you are just a student and you have some sort of a portfolio website, or if you have built a project for your college, you can simply use App Runner to show that particular project to your teammates or your classmates, everything. You can use App Runner because it simplifies all the aspects, and you want the fastest path to the production. So using this App Runner service, you can simply deploy your application to the production grade system where you are not managing anything. Everything such as scaling, traffic management is handled by App Runner. So it is very simple service, and I often recommend this App Runner to people who are just starting out in the container ecosystem or building MVPs. Because I myself, when I was new to container ecosystem, I was using App Runner to host my simple applications, portfolio websites, etc. So this is a summary about App Runner. Now we'll have a quick service table comparison, right, to just understand basically what we have saw till now, right? So when deciding between ECS, EKS, and App Runner, you will need some sort of understanding of complexity, operational effort, which is ops effort, and if your team has the capability to use those services, right? So as you can see on the header, we can see complexity, ops effort, and best for. and we have 3 services here. So as you can see, ECS has a very low complexity, very low ops effort, and it is best for AWS native microservices, because we have seen it is a container system which can scale to a very vast level, and it does not ask you to manage a lot of things in terms of container runtime and everything. AWS takes care of it, hence the complexity is low and operational effort is also low. You just have to provide your application image, and ECS will take care of deploying and scaling in and scaling out using ASGs, auto scaling groups. And it is very helpful for AWS native microservices because it has a lot of integrations with AWS services such as SQS. You have then you have ECR, etc., EC2, Fargate, all those things. Then coming to EKS, as I already mentioned, it has a very high complexity. It has medium to high operational effort, as your teams need to know first all the fundamentals about Kubernetes systems, how they run, how they get deployed. Then you will need to use EKS service. So it is for those people who have a very large enterprise teams. They are running their applications or an enterprise scale. They are having millions of traffic. Then definitely EKS is a service for them to go. And last but not the least, App Runner is something which is having very low complexity. As we have seen, App Runner simply takes your application image. You just have to click on one button, deploy, and it will deploy your application. It will give you the domain as well. You don't have to purchase domain. It will give you domain. Only if you need your custom domain, then only you have to have that attached. Otherwise, you can get your application running within 5 minutes using App Runner. Hence, its complexity is very low. There are almost minimal to none operational effort, where you do not manage any server, you do not manage anything regarding your container runtime, and hence it has a very low operational effort. And hence it is best for simple web apps, people who are just starting out, people who are web developers, or they want to just build an MVP for their startups. They have some idea which they want to get into production very soon. Then they can definitely use App Runner. I'll definitely highly recommend it. So this table basically summarizes the mental model. If simplicity is your goal, choose App Runner or ECS at max. If flexibility and EKS Kubernetes, Kubernetes ecosystem matters to you or your team, you can definitely go for EKS. That's what the summary of this table is about. Now I have put one slide together for a decision framework also, right? So it's a simple framework. Of course, everyone wants a straightforward rule, right? People ask you what service should I use? I have this use case, and how do you decide this will be best for me in long run, right? So these two are the simple questions. So first question is, do you need Kubernetes? If your team needs Kubernetes and the answer is yes, you should go to EKS. No worries. If your answer is no, you do not need Kubernetes, then you can definitely go. Just think about ECS and App Runner. It will definitely immediately reduces your thinking effort and decision making to 50%. You just have two services to choose from. Then among ECS and App Runner, do you prefer infrastructure control or simplicity, right? If you prefer infrastructure control, where you want to see and manage some aspects of your container runtime, then you can definitely go to ECS, as it provides you with some sort of scaling options, scaling policies, using which you can scale up, scale down your containers. Then you can definitely go to ECS. And if only simplicity is your goal and you want quick turnout for your application, and if you want to go to market very soon for your MVP or for your product, then App Runner is your way to go. So these two fundamental questions will definitely help you choose a right container service for your applications. And these questions will get you to the right service 90% of the time, right? I know it sounds very simple, but always we try to look for complex things, but we miss these basic things. So you can definitely have these two things in your mind and take your decision accordingly. Now coming to the almost end of my session, and what I'll just present a summary of what we saw throughout the session. So there are a few key takeaways. AWS has a container service for every need. As I mentioned, if you need Kubernetes, you have EKS. If you need to just run container with some more granular control, you have ECS. If you need very fast and if you don't want to manage any infrastructure, you have app runner. So basically AWS has a whole lot of landscape and suite of services through which you can choose your favorite container service or favorable or most suitable container service for your applications. Then you can start with the simplest option. As I mentioned, if you are someone who are just starting out in container ecosystem, I have already recommended the app runner service for that. Then use EKS only if Kubernetes is required. EKS is not for everyone. I'm repeating this again. And Fargate simplifies infra management. So ECS and EKS use Fargate as their compute. Fargate is a serverless compute option where you do not need to manage the memory, CPU requirements, or hardware requirements. It takes care of all those things on its own since it's serverless. And again, last but not least, think use case first, technology second, right? So most of the times what we do is we try to select the service for, like, okay, we have heard about EKS and it's a container service by AWS, so we'll just think about it like using that service without even having to understand what is your use case, what will be our traffic, will be our user base, will our application need that much resources, are we over provisioning or we under provisioning. Without that choice, you cannot select the service. So always think about your use case first. What is your use case? What will be required for your application? And then only select the right technology or right container service. Containers are powerful, but choosing the right service is what makes them effective. So with that, I'll just open the forum for any questions, and then probably I'll wrap up my session.
Hey, hi, Abhishek. That was a wonderful session, and thanks for the summary. And especially, I like the last statement that you made, that go for the use case, then think about the technology. And I think that's something that I would also really take away from your session. So we have a couple of questions from the folks, very familiar and very active folks from UG Madurai as usual. So we have Bhavesh and a lot of other folks. So we'll take quickly a couple of questions, and maybe you might have addressed it in your session, but
Yeah,
we'll talk about it in detail in the Q&A as well. So Bhavesh
sure.
is asking, everyone knows who's Bhavesh. So yeah, so Bhavesh is asking, like, what's the main advantage or and the disadvantage of using ECS over EKS, or vice versa, if that's the case.
Yep. So first of all, the major thing which I have not, of course, addressed in my session because the session was not about optimizations, but first thing comes to my mind when I hear that question is cost, right? If you are experienced team or if you are an experienced enterprise, while choosing the services in between ECS and EKS, the main things comes to cost and complexity. So first thing, EKS is not very cost optimized.
Mhm.
Has an additional cost. If you run or not, cluster takes the creation of cluster takes its cost, such as RDS. If you know RDS, if you spin up an instance, you'll definitely need to pay even if you use or not, right? So ECS is something called ECS's model of costing is based on traffic requests also and running instances, right? So ECS have main advantage where you can optimize your cost. It gives you simplicity in managing your containers, and it gives you a granular control over how your scaling policies are, right? So let's say in my personal use case, I've been using ECS and EKS also. In my company, if we are using ECS, we have added some auto scaling policies to our ECS ecosystem. When our applications are when our applications are not receiving that much traffic from our B2B customers, we are not showing we are not scaling it up. We are having very lean server ecosystem where we can optimize our cost. But if you have EKS, even if while using EKS scaling policies, you cannot reduce that much amount of cost. You cannot optimize that much. So the main advantage of ECS and EKS, ECS is of course more cost optimized. EKS is slightly overpriced. Disadvantages of using ECS, I won't call it as a disadvantage, but basically, if your application needs, have a lot of containers, and if your application is serving a lot of customers, a lot of traffic, then most of the times you will need to take care of scaling, right? But if you are using EKS, it gives you more flexibility, catering to the customers, having a lot of scale in your hand, and without managing the deployments. It can take your replica sets, it can deploy a lot of configurations on its own. It can also check, or what we can say, heal self-healing containers, right? So even if your some application containers are down, EKS can take care of that. So there are a lot of add-on additional services in EKS which ECS does not provide. But again, it's not a disadvantage, it's just a use case friendly option which we have to choose from. But definitely cost is the main factor before choosing the ECS and EKS. So yeah, I hope that addresses the question.
Yeah, it was great. Like, we have a few more questions. I just add. Yeah, there's a question from
Okay.
Yogesh.
Are there any cost pitfalls that the teams often overlook when selecting a container orchestration service in AWS? I think the similar thing which I addressed Bhavesh's question on, that definitely there are costs involved in selecting the container services. But again, I won't say it as a pitfall or disadvantage, because if you are choosing EKS or ECS, it comes with some additional things which you need, right? It's not something like you are getting same things in ECS and EKS, and EKS is charging you more. It's not like that. If you are paying more to EKS, it definitely comes with flexibility, more granular control over your deployments or your scaling, auto scaling, cost optimized way. So yeah, there are cost pitfalls, but it is depending on the use case, and it's not some sort of a disadvantage by design. Hope that answers the question.
That answers the question. Yes, and there is this is like a very popular, like very common question that we keep
Yes,
hearing always.
yes,
Like it's always like whether we have to go for App Runner or Beanstalk.
yes.
Uh, so in that case, like what is your take on this?
So my personal take, okay, since Bhavesh is asking suitable for Node.js app, I am definitely gonna say him app runner. Not because I favor containers the most, but the thing is, as I mentioned, I wanted to have the app runner demo here as well, but due to the time constraint, I couldn't. But if you have seen the app runner console, right, it is very simple and beginner friendly. You can literally create or use public Docker image. You just have to paste the image in App Runner console, and you just have to click on deploy, right? And
Hmm. Yeah.
within 5 minutes, and just pasting the Docker image and just clicking on deploy can take you to dev to production in 5 to 10 minutes. So this is what I've already worked upon Beanstalk as well, App Runner as well. But I think if I wanted to recommend something for very beginner friendly Node.js or Python app runner is the way to go. If nobody has tried app runner yet and they have used Beanstalk, I'll suggest them to just give one chance to app runner, and you'll definitely choose app runner going forward.
Yeah, and I think we have one last question here. So from
Yeah.
Dinesh, Dinesh is asking about like what are the instances that you actually choose Amplify over App Runner for containerized
Yeah.
applications? Okay, I
Okay.
think the answer is pretty straightforward, but yeah, you can take it up.
Yeah.
Yeah.
So basically, Amplify is not something which you use for containerized applications. Amplify is something which gives you a simplified way of getting your applications running with microservice architecture, something like that, right? So let's say if you do not have much idea on provisioning infrastructure, but you are just a developer, right? So
Yes.
Amplify might, in that case, Amplify helps you because it creates databases on your behalf, be it SQL or no SQL. Then it creates REST or GraphQL based APIs, so you can choose either one of them, and it can run lambdas on your behalf where you can host your application code. and you can have authentication such as cognitive everything. So these things are mostly helpful for distributed and microservice architecture. So it's a whole different thing, I'll say. App runner is a whole different thing. It's just a containerized instance where your application gets a container assigned to it and runs in that container. So if again, it's not something related to container, but if you are something who don't want to use container and just want to have their separate database, authentication service, even front end components are supported by Amplify. So if you want a full stack application, then definitely you can use Amplify. Hope that clears up the question.
Yeah, absolutely. Yep. So if you're a person who's pretty new and who don't want to take the hassle of all this
Yes.
managing the infra for yourself, and you want everything needs to be done by AWS for you, so I think you should go for Amplify. So it's always a trade-off that we have here. So how much of a
Yes.
control that you have over the infrastructure versus how much you want to invest in it. So
Yeah.
in that case, that would have. But since it's containerized application, it's a straight answer of to going to App Runner. That would be also my case. And yeah, we have
And
App Runner team always supporting here as well. So more than Beanstalk, I think, and we also have figured out like why and what is the best aspects
yeah,
around it.
I've seen Jones comment on
Yeah, yeah,
that app runner been stock.
true,
Definitely,
true that.
I'll go for app runner. Yep.
Perfect. So I'll ask one last question to you personally,
Yep.
but it's not a technical question. But
Yes.
so we had very nice elaboration and explanation that why we need to go for for what ends, use case and everything. But can you just let me know, like based on your building experiences and your developer experience, where have you stuck while doing, like maybe you might be deploying over something, your application over ECS and stuff, and you ran into something that made you go crazy, something like that? Do you have any instance or account like that?
Definitely, definitely. Recently, one instance I've been using and debugging one thing regarding ECS. So basically, our applications run on ECS, right?
Yeah.
And then one of the developers pushed a code using one dependency. Let's say when we use something called as import XYZ, import something, right?
Hmm.
He imported it on his local machine. He tested it. Everything worked fine. He just pushed, but he missed that one dependency to add into requirements.txt file, right?
Hmm.
So it worked on
Yes.
his local. He pushed the code. It went to the container. Container was and basically we use app deploy for our CI/CD, right?
Yep.
So it takes care of deploying to the ECS our image. And what was happening is our container was not getting up and running, but we are also not seeing any errors as such because
Oh,
application
okay.
was good. Then usually we get that import module not found error when you locally do not found any module or dependency. So basically what we had to do is we had to go to code deploy, find out the failing deployment. And one major issue is when there is a 1 hour window. If within 1 hour you are not able to see the logs, the deployment
Hmm.
and the failing container will get terminated and you won't see the logs again. So it's been
Great.
like 1 or 2 hours. We were not able to see any log why it's failing, and the containers are continuously failing. Application was down. So what we did is then again we found out we ran the failed deployment once again. Then within that 1 hour window, we went to the code deploy. We found out failing instance. We went to internal logs. Then there I found that module not found error finally, and then we resolved that dependency issues, added that to requirement.txt, and then got it deployed again, and it was done and dusted. Not a major thing, but very frustrating.
I think it sounds pretty frustrating. Yeah.
Yeah,
And guys, if you're missing out some action, there is a cool conversations going in our chat. You can
yeah,
jump in and you can let us know. And Jones is actually keeping two teams apart. So yeah, if you want to join the fight, join a chat session as well. So great. That was amazing session, Abhishek. Really loved it. So for people who are very new to containers, this was an amazing session for you to get clarity on the concepts. And I think if you have some projects already lying in your local computer, I think it's right now for you to push and make it public and go it live. And you have the options right now to make it go live. And you learned something new today. So amazing session for that. And moving forward, we are now going
yeah.
to learn something more bit advanced. And we're going to talk more about EKS Auto Mode and from the very own our expert Zach. And meanwhile, when Jones is trying to gather some support on serverless, Team Serverless, we are going to show our support for Zach here, and then we're going to learn something new here. So welcome, Zach, and I'm really excited for your session because I'm truly a beginner in this, and I'm already with my notes here, so I'm going to sit and learn for something new today. So I hope everyone is also here for the same, and over to you.
Oh, thank you. Let me first start the slideshow mode. Sweet ass. Vanakkam Madurai again, and thank you so much, Vivek and the team, for inviting me. And Zach, I can see Zach also watching this. Let's see CKSO serverless. Yeah, before we get started, I would to give some disclaimers because this session is not a beginner session, because I hope anyone's having any questions later, I'm more than happy to answer. But this session is more, we are going deep dive into EKS Auto Mode, and EKS Auto Mode, how to manage the custom node classes, node tools. So I would like to give the disclaimer, and I have created a small a code base, I would say some YAML manifest. Later you can write your own with the EKS Auto Mode cluster, but those make sure it's not suitable for production, because make sure you have to align with your company policies, organization policies, and all the other configurations. Cool. Let's jump in. Oops, I can see my QR code is covered, but if you want to search me on, like, go and search in LinkedIn. Yeah, I'm Arshad Zakaria, aka Zach. People calls me Zach with K. People call Jones with Zach with H. And yeah, I'm AWS hero from New Zealand, and I manage the user group Wellington, AWS user group Wellington, with another amazing people from Wellington as well. And a platform engineer, mainly on the Kubernetes side, specialized in EKS. And you can see my lovely family, husband, collecting Legos. I love Legos. That's my favorite hobby, one of the favorite hobbies. And I love cooking. Trust me, I can cook. Same like I do Kubernetes. And I love traveling. I travel a lot with my wife around the world, and there are a lot of countries to travel as well. Nice. So our session is mainly about these 5 things. We're gonna do a kind of recap. Like, we want to recall what is the EKS Auto Mode, and give kind of a glance about it. We are gonna deep dive into what are node pools, node classes, and how we can configure customer node pool and node classes. And later on, we have a demo. I'm gonna do a live demo. I trust myself. Hope the demo goes with me today. And then we'll do a nice recap, and I can share some resources. And if you have any question, I would love to answer. Cool. And another thing, I don't have only one slide. I'll be shifting around tabs and sharing some documents while doing it, so bear with me. So EKS Auto Mode is announced last year at reInvent. That's one of my favorite announcement, if I'm not wrong, last year reInvent. And it's basically comes with the managed Carpenter, and we are gonna deep dive into more auto mode features later. And since we are talking about node class and node pools, I'm gonna talk about the Carpenter capability, and AWS manage the Carpenter control for us. I'll explain you in bit later about that. And our job is like a platform engineer. You can be a DevOps engineer or system engineer, name whatever you want. Our main job is to manage the customizations of these cluster, like node pools, node classes, give the opportunity for the developers so they don't have to worry. They can deploy their application to whatever they want, and depends on their requirement. So the auto part, this is what I love. We don't have to manage. We don't have to worry about the how to manage the Carpenter controllers or the patching or the versionings, because it's another managed service. AWS will be taking care of it. So let me quickly jump in to the EKS Auto Mode documentation. So I love this diagram. Let me make it a little bit more bigger. Okay, the page is big. Okay, fine. Cool. So you can see the difference, right? Like there are 2 images. The left side, we can see the auto mode, and the standard mode, you can see the right side. So AWS, we have something called shared user responsibility model. So how these shared user responsibility model is divided, like certain things AWS managed it, certain things as customers we are responsible for that. So in the let's talk about the standard mode. In the standard mode, you can see the global infrastructure, basically regions, availability zones, the local zones, its locations, everything's are managed by AWS. And the fundamental services like compute, storage, the EBS volumes for storage, the networking like VPC, monitoring, and everything, it's managed by, the hardware part of it, the managed by the AWS. Then the EKS cluster control plane. So the EKS cluster, and thanks to Abhishek, he covered the most thing about what is EKS, so I don't have to go in detail about EKS as I mentioned. So EKS comes in a lot of components like controllers, API server, XC database, schedulers, so many things comes with the package when you get an EKS cluster. So it's managed by the AWS. Then we have something called capabilities. If you remember, Abhishek was talking about something called add-ons. So when you set up a Kubernetes cluster, by default, you cannot just go and deploy things first because it needs something for like core add-ons, because those are the crucial add-ons to have a workable cluster. So the first thing I would say, the networking part, something called VPC CNI. There are other CNI tools as well. And for ingress, we should have something like a load balancer controllers and storage drivers like EBS CSI volume drivers, and the auto scaling. So auto scaling is the main part we are going to talk about, because the auto scaling capability, we have different tools. So if you heard about cluster auto scaler, it's a very common tool. Then something called Carpenter. Carpenter also, it's a well-known tool now. A lot of people adapt into Carpenter because it's amazing simply. And let's talk about Carpenter in a bit later. Then the cluster EC2 instances. So a standard EKS cluster, you can have either Fargate, which is like a serverless platform for the worker nodes, and we can have EC2 instances. So the EC2 instances, it's very hard to have like something called like life cycling patches, because let's say you have a cluster which runs like thousands of nodes and you want to patch those things. And if you're managing something like self-managed node groups, it's very hard, right? Because you have to do something like node rolling, patch the nodes, and evict the pods. It had to be very granularly done. And it's not easy, to be honest, as a day-to-day of a EKS platform engineer. Then the patching part, because AWS usually, if I'm not wrong, they release a latest AMI once a week, and it contains all the security patches and all the latest things. So then monitoring, health and repair, everything's supposed to be managed by us on a standard mode. Then we have system agent, kubelet, container runtime, all those things. So application containers, the container availability, the securities, like Abhishek mentioned, like when you're containerizing application, you have to make sure what are the packages inside. Let's say it's a Python package, there could be Python libraries. You have to make sure it's all up to date. So it's our responsibility to manage it, right? Then the VPC infrastructure. So this is the VPC infrastructure custom managed, and the foundation service networking is the mainly AWS managed. So the VPC is the one of the core thing when you start to create EKS cluster, because IP version v4, there are less number of IPs you can create, right, compared to IPv6. So planning the VPC and subnettings, it's very crucial. It should be done by a network expert, because make sure you have to predict how is the workload going to be in the future, and you can share the subnet, share VPCs. It can be done, but make sure everything you should not end up in a situation like something happened like IP extortions and everything. And I don't manage it obviously, right? Because Kubernetes is the best part because it's cloud native. You can have all the cloud native add-ons. Like if you want to have like, so if you're talking about event driven, so we have KEDA, Kubernetes event driven auto scaling. So you can have a KDAP add-on installed, and you can scale your application, depends on the events. So there are so many add-ons. And we can clearly see the difference. If you come to the EKS Auto Mode side, the cluster EC2 instances, cluster capabilities are gone. The reason, when you install a EKS Auto Mode cluster, the capabilities which is like core add-ons, core proxy, VPC CNI, core DNS, AWS ALB load balancer controllers, EBSCS drives, and if I'm not wrong, pod identity. All these add-ons are running as a daemon inside the worker nodes, which means we don't have to manage or install. It's out of the box. When you install EKS Auto Mode cluster, basically it's ready to deploy your application. You don't have to do anything. Yes, you have to do your application deployment, but you don't have to worry about installing add-ons. But top of that, yes, you can install add-ons. Like if you want to install like observability platforms, like let's say a third-party platform like Neuralink, you want to add something, install like Pixie, yes, you can install it. Then as customers, yes, we have to make sure which VPC we are going to install the EKS Auto Mode cluster, and how are we going to package our container application, and where are we going to store it, and all the other third-party add-ons, and the subnetting, security, IAM, all those things. So this is a glance of like what is EKS Auto Mode and what is standard mode, but we are not going to talk about EKS Auto Mode today, because we are going to talk something else. Mainly, I'm going to cover the complete auto scaling part of the Auto Mode, where Auto Mode by default it comes with something called Carpenter. It's cluster auto scaler. We don't have to install or manage anything for Carpenter. It comes out of the box of EKS Auto Mode. Let me jump back to my slides again. Sweet. Cool. So, but there is always a but, right? Because when everything goes smooth, but so far these things are kind of like impossible to do, because with the Auto Mode, because we have to expect that, right? Because if you're asking for a full automated service, and which means as a customer we should not worry about things and let AWS take care of this certain things. But still, there are certain things we should be able to manage. So, but that flexibility is given by AWS. I received a call from one of my friends actually, and they deploy something in EKS Auto Mode, and they said, okay, something happened, like suddenly pod start crash, because the Carpenter, how it works, if you're not properly configure the Carpenter to do the bin packing or consultations and everything, it will basically just go ahead and try to save your cost, because the Carpenter is one of the tools trying to save the cost. A lot of organization installing Carpenter because one of the reasons, save the cost, find the right compute for your application, and so it's doing its job. But we have to be very careful what you're doing, right? So the other thing is, some team members, let's say it's a big organization, you have like 3,000 developers, and some application they need like stateless applications. Some teams need like stateful applications, and you can ask, why Zach, you can use Lambda, right? But yes, we are not going to talk about Lambda for stateless application. We are going to talk about EKS Auto Mode today. And something like jobs, like say Electron jobs, right? So you want to run some Vivek loves ML stuff, right? So you want to run some ML job. So it needs a different kind of workloads, like GPU nodes. And some are trying to use less cost and trying to using ARM architecture. And these different needs. So one size fits none, right? You need to have different sizes for different workloads. And this is how you rightly manage and reduce the cost and give the high efficiency about your workloads. And the other part is, when you install EKS Auto Mode cluster, you have option. Either you can go with built-in node class and node pools. So there are going to be two node pools. One is a general, one is the system node pool. So system node pool, they're using taints. So only the critical add-ons can be deployed to those node pools. And the general one, basically you can deploy anything. Once you deploy the cluster, you can just deploy your workload and up and running. But there are some issues, like especially the tagging of EC2 instances. So if you're in high enterprise organization, you might know already, you can't just go and create EC2 instance in your AWS account, right? Accounts, maybe multiple accounts, because there's a process. You have to tag your instances. Otherwise, your compliance team not going to be happy. They're going to come and ask, okay, who created this instance? I can't see any team name or anything, right? And your cost team going to be very unhappy because they can't create their bills. They don't know which teams owns these instances. Then they have something like cloud custodian jobs are running. Like they check, okay, if there is a untagged EC2 instance, just go and delete it. So these are the problems. So unfortunately, the current setup, like when you create EKS Auto Mode cluster, you can't edit the default node pool node classes. So that is a known thing. And if you want to use custom IAM roles and subnet selectors, so recently EKS Auto Mode announced something like for pods, you can have custom subnets. So let's say you have where you have an organization that they have multiple subnet, it's shared using RAM, and you want to select your subnets in different terms. In that case, you need to have multiple, different custom node classes, node pools to get these things done. Cool. So this is a very core concept. I like this analogy. So node pool is what, and node class is like how. So in the node class, we just mention like what are the IAM roles and subnets, security groups, tags. There are other specs as well. So later on, we'll go through those documentation. I can show you. And the node pools, like what? Basically, what instance type I want and what capacity type, whether it's a spot instance or on demand, and the architecture is ARM64 or AMD64, and what are the taints we can use, and what are the labels. If you have any custom labels we can use, especially like if you have any observability platform, like you want to get your node logs or anything, like you want to add some custom labels for the nodes, specifically identify those things. And disruption rules. So the disruption, what I was talking about, my friend had the issue, is workloads disrupted because they just use the vanilla general node pool to deploy their workloads. Cool. So when to customize? So the first thing, if you want to have, like I mentioned, if you have any specific subnets and you want to customize your node classes to, okay, these are the subnets I'm going to deploy these node pools. And you might have different subnets from the different accounts. And again, I'm going to keep talk about the tag because this is one of the bottleneck, I would say. And GPU and ARM specialization. So which compute type, like, is a GPU based one or ARM based one, which one you want, like then the pod can schedule. And the taint and toleration, we are using here the mechanism to taint the nodes and tolerate your workload to deploy in that specific nodes. Then steady and bursty. So some pods, some workloads should be able to have a disruption, like let's say it's a deployment and that application has developed as to face any disruptions, like if it's running like 10 replica sets, anytime 2 or 3 replicas can go down, so that should be fine. So let's say some edge case, there could be a very a single pod is running, which means when there's a pod eviction, definitely the pod gonna be stop and recreate, right? By that time there will be downtime, so we have to make sure how to tolerate those things. So, and for the bursty services, like and it just come out of nowhere suddenly and just go down, and we can use something like spot instances. For that, we can have separate node pool for that. Cool. So the how part, the node classes. So this is a very simple node class YAML template here, for example. And here you can see this is for an ARM-based architecture. And we have to mention, there are key things to mention here. One is the IAM role. So IAM role is basically, when you create your EKS Auto Mode cluster, the node will using these IAM roles to connect the cluster. Either you can take the same role. For the demo purpose, I took the same role, or else you can create a specific role, and you can create a Kubernetes access, EKS access entry, and give the relevant permission, so it will able to connect it. And subnet selector terms. So here I'm using the selector terms, as I have two tags here. One is tag Feijoa, that is my favorite fruit. It's very famous in New Zealand. Everyone knows I love that fruit. So the other one is, so when you create the create a VPC subnet for an EKS cluster. So for your private subnet, you have this internal -lb1, which is the common tag I'm using here, and the security group term selectors. I'm using the security group tag, which is my cluster name here. But I'm gonna show you quickly something before we go ahead. So this is my cluster, and I'm going to the networking cluster security group. See it. So there are multiple tags, right? So I'm using this tag. So let's say if you have a different tag, you can have these subnet selector terms, and you can select according to that. So we are back to this. Nice. And I can set up the storage and the tags. So we are talking about the tags, right? So the tags, we can set it up here. So later when we do the demo, we can see all the nodes spin up using this node class. It's going to have all these tags. Cool. And let's go to the node pools. So the what part? In the node pool, definitely we have to reference, okay, this is my node class I'm going to use in this node pool. So here, I don't know, it can see, I think should be able to see. Sorry. Okay, node class reference here. Oh, you can't see my mouse, right? I'm so sorry. I don't have a laser here to show you, but if you see the line 13 to 15, but don't worry, later we are going through the code, I can show you. We have to reference what is the node class I'm going to use. And termination grace period, here we are setting as 24 hours, but EKS Auto Mode by default, it comes as 24 hours as well. As a demo purpose, I just kept it as it is. And taint and tolerations, taints I'm using from line 32, 32, 31 to 32. You can see the architecture is ARM64. Then I have a couple of requirements here, like as I mentioned in the slide, this is the menu that you're going to pick up. Like if you're doing, if you're going to order food, or if you're going, like let's say you're going shopping, okay, this kind of requirement I need. Let's say you're building a gaming PC, this kind of RAM I want, and everything, right? So these labels are, we can pick which kind of EC2 instances we need in our cluster. So before we go ahead to the next one, so EKS Auto Mode supports some labels, but you can see a note here. EKS Auto Mode uses different labels and carpenter. Yes, so certain labels start with eks.amazonaws.com, which means these are only supported in EKS Auto Mode. If you have a self-install carpenter, it doesn't work. In a self-hosted carpenter, it will work in a different way, which means the label name is going to be changed. That's the only difference here. Then a main thing to notice here, in the previous session, Abhishek, I think nobody asked about Windows workload, right? I don't remember someone's asking from Abhishek about the Windows workload. So EKS Auto Mode doesn't support Windows workload, but if you're going to use EKS in a standard mode, yes, you should be able to use it. So Node Kubernetes.io Windows build are not supported, and we can't pick up the OS as well. The reason is that EKS Auto Mode comes in something called Bottle Rocket OS. So the Bottle Rocket is optimized for containers to run. So that's the reason AWS, EKS Auto Mode comes with a lot of managed services. This is the operating system is going to be used. And the one thing, you can't SSH into these instances as well. Yeah. Which is cool in a way, because production should be immutable. So, yeah, so, and we can set the disruptions. So in the disruption here, line 37 to 38, cancellation policies when empty or underutilized. So which means, like in Carpenter terms, if it's when empty or underutilized, it will do after 6 minutes, it will check, and it will do this disruption always, cancellation, because that's the beauty of Carpenter, because it always check, okay, this is a big ship and we are running small container boxes, and we can move this to a small ship. So it will try to check this, and it's do something called bin packing. It will try to put everything in to one ship and pack it properly without any gap between. So it's which means like try to use the node much as possible. Cool. Then the workloads. So we talk about EKS for the Auto Mode for like node classes and node pools. So node pool basically is the gate, and the workload, like say it's a deployment, it can be a job. In this case, I'm using a deployment, and it can be a stateful set. So the keys here, as the deployment, we are using something called toleration. So if you see the line 9 to 16, I'm using toleration and node selectors to pick, okay, I have to deploy this one in the ARM64. And in the gate side, the node pool, it's tainted our nodes saying that, okay, it's ARM64. So which means this application will be deployed only in this one, and this node will not accept anything else apart from that. Cool. Wizard Zach is here. Thanks, Johns, for the amazing gift. And I think let's dive into some live demo and go through the code, and let's play around with it. I think everyone loves demo, right? Cool. And we have our friend Kiro here. So I have 3 folders. So before I go ahead, I'll check my private chat here. Hope everyone can see my font size. Is it okay? Okay, cool. Vivek confirmed. It's good. Sweet ass. Okay, let's start with node classes. So we are going to create the node classes. So here I have 5 examples and 5 example of node pools, which is going to be referenced by here, and some workloads, including some pod disruption budget. So the first node class, as I mentioned, is IAM role, and this for the ARM64, and my stack name is Fedora. The reason for that, yes, I love that fruit a lot. And if I go to tags, so you can see the stack Fedora here. Cool. And yes, I'm keeping that tag for each and every resource here for give some standardization. And billing team name is Zach team, and environment is dev, and workload type I'm going to put as ARM64. Later on, let's say if you want to generate some reports, this is going to be really easy, right? When you have different tags, so you can isolate, segregate your reports and everything. Then I have a custom default node class. So this is for like a default one. Most of the, like, let's say 80% or 70% of your workload can be done. It's not a very special thing. It's a very a default one. And the GPU, which is like Vivek might be love to use it because he works on a lot of AI ML stuff. So GPUs are the things. So this is for the GPU, and you can notice it's not big difference, right? It could be same. Only the names and the text are difference here. The reason behind this, it's better to have as a best practice to segregate your node classes. Otherwise, you can have one node class and you can have multiple node pools. Later, I will show you the AWS default node class and node pool, how they configured. Yeah, you can have one node class and you can have multiple node pools, and you can reference those things. But I would love to have in this way because it's my personal opinion that if you segregate things, it's easy to change and easy to maintain, I would say. Let's go to the node pool. The node pool has some labels. This for the ARM64, and here the node class reference. You see, it's a node class name, and the node class name referring there in the right way. And this is the shopping list. We go and shopping now. Okay, I need ARM64 is on demand. It could be C series or M general purpose or compute optimized, or the instant CPU. I'm putting as like 4 to 32. This for the demo purpose, and I'm going to taint my nodes using these taints. And the CPU limit for this node pool, here I'm setting as 1000 CPUs. We can configure these values as well. Cool. And the consolidation policy is when MTO underutilized. Carpenter support different consolidation policies. You can use a different way, and we can define when this should be able to consolidate. And custom default one, I'm showing like this, so easy to see. I have something different here. So intentionally I put because I wanted to show you how we can manage budgets, but later on I have a good example how you can avoid like sudden expectation, like something to happen to my friend. So here 10% of node can be consolidated every 6 hours in 1 hour duration. So this is something granularly you can configure. So which means you can play around these numbers. So that is what custom node pools, node classes can help you here, because AWS has its own default values. You can find those numbers on their documentations, very well defined. Later on, I'll show you as well. But which means we can play around with this. And GPU, same here. I'm looking for a G series and on demand. And the spot instance, you can see the capacity type. I'm using a spot. I need a spot one here. And the spot instance are very cheaper. And because of that, I just tried to put like C, M, and memory optimize as well. It doesn't matter. It's for demo purpose. And same as it is, and the stable workload. So this is a costly workload, because here we are these configurations almost similar because we are running AMD 64 and on demand, but here a budget is a bit different. So here we have something like a maintenance window. So this is a 1 week thing. So I have configured like 100%. This is not good for production, to be honest, but for the demo purpose, I did this. And here what I'm saying, the time, it's 8 a.m. Monday morning. As far as I know, time zones are still not be able to configure via budgets. But if anyone know, please put in the comment. Maybe I can add that one as well. But it's in UTC time, and the duration is 6 hours. And reasons could be drifted, which means if any new AMI released, and or any changes in the node pool, EKS, the node pool, node class configurations. It's like let's say you have a deployment running in the Kubernetes cluster, and you're making a change for your container version or something, and it should recreate the new pods, right? Something like that. So it will check for any drifts. And if it's empty or reasons, or here I'm putting all the 3 reasons, and If you leave it blank, it will use all the three reasons by default. And in this scenario, it can go up to 6 hours disruption. So which means any workload, any pods, any jobs running in this node pool, stable node pool, can disrupt Monday morning 6 hours up from 8 to 6 hours means like it's 2 p.m. So that's why after 2 p.m., what we are going to do, we are saying to Carpenter, okay, after 2 p.m. until next week Monday morning, the disruption is 0. Listen to me carefully. So Monday morning, 6 hours, you can disrupt your workload, like disrupt your nodes in this node pool. But after 2 p.m., you can't disrupt. So that's why 0. What we'll do, it respect this node disruption. It will wait until next week, Monday morning, and then only that time period it will happen. So this is a very a unique scenario, and there are other nice scenarios in Carpenter documentation because different organization needs a different way of doing it, right? So that's why it's what I want to show you, that it's flexible and it's Carpenter basically, right? So you can use the Carpenter configurations here, and you can control your disruptions, I would say. Then I have some little bit of testing workload for ARM, and it's a deployment and the pod disruption budget. Then we have deployment for this for the custom default and the GPU. I would say this is a Vivek's deployment, and for the spot instance, for a spot deployment, and I have a stateful set for the stable workload. The purpose of this demo, obviously. Cool. So everyone ready? Let's go and deploy. So the first thing, we have to create our EC2 node classes, right? So the node class, I'm going to apply. Cool. So node class is created. So we can check node classes. I really love these Amazon Q CLI auto prompt. It's amazing. Is it ready? Unknown. True. Cool. So my older node classes are ready now. So let's do deploy the node pools. Sweet. Node pools are ready. True, but no nodes are running. So this is the default node pool deployed by the AWS. So basically, its name is system. So if I get node pools for node classes, you can see there's a default one. So the one default node class, if I get node pools, their system and general purpose. It's using the default node class. That's what I mentioned before. You can have one node class and reference in multiple node pools, but in our case, we have created separate node pools and node classes to make it easy to understand, and I would say the best practice. And if I get nodes, I can see only one node is running. Node claims. Sorry. Okay, Carpenter has created an on-demand node claim, and there's a node running. It's a C6G large. This from the system. This is for get pods, because kube state metric and which is KSM, and the metric server pods are running there. So that's why it's because I already deployed those things to for my other some testing project. But yeah, it's already running. Now let's deploy our workload. That is most important one, right? Because we can't see any. I would say deploy. Sorry, apply. test workload. Cool. Everything in the default namespace. So we have 5 workloads, but I don't have a pod disruption budget for the static workload because it's intentional, because we wanted to make sure it's running in a single pod, so that's why. And we have let's say, okay, get a deploy. We should have 4 deployments, and I should have one more stateful set. So this is static world. So these are not ready yet. It's 32 seconds ago. The deployments are not ready yet because, but spot one came very fast. So okay, get node claims. Cool. So spot one came very, very fast. So it got me a C5 AD.xlarge, and the GPU node is ready. Custom workload one is ready. So if I get K nodes now, I can see the nodes are running now. So the workloads are running. Let me, okay, which one to go first? Okay, before go to the thing, I'll go to the console and okay. So managed by stable workload, spot workload, GPU, custom default workload, and ARM64. So let's click the GPU one. And let me scroll down. So you can see it's using the NVIDIA EKS Auto NVIDIA. My Kubernetes version is 1.34. The AMI version here, so which supposed to be a AMI for a GPU workload, obviously, right? Otherwise, I would be freak out. And the tags, again, Zach is going to talk about tags. So there are certain tags managed by the EKS Auto Mode. Some tags, remember, I included, right? So, for example, the billing team from Zach team, workload type, GPU. So this is what I was talking about, like the tags I could be able to add. So will be this one will be a good news for security compliance team and the your cost team, like who's managing the cost. Cool. So the overall things we have done, I'm gonna show in a single glance. I love this tool. It's called Headlamp. It's an open source tool. But disclaimer: this not support officially. The plugin is not supported for EKS Auto Mode, the Carpenter plugin, which they announced recently. But I have raised a PR to make it happen. But they already made the PR, and they mentioned they're going to release this feature soon for the EKS Auto Mode. But if you have a Carpenter self-manage, it supports. It's amazing. So I am already in my cluster. I'm gonna go for my Carpenter. Nice. So let's start with the default, which is created by AWS. So there are 2 node pools. You can see the reference nicely here. 1 node class, 2 node pools can be used, and node claim is created. It's like the claim, I like that icon, the hand claiming it, and it creates a node, and it's running my metric server and kube state metric pod in that one. But let's jump into GPU workload. Wait. Since I run the plugin in local, I think it has to be refreshed. Yes. Okay. So the GPU workload, you can see this is I created, and the node pool, node class, and the node pool claim created. It created the instance, and the deployment is running successfully. Let's say it's a Vivek's GPU pod. It's running. Amazing, eh? Yeah. So I love this view because it's very clear to see what's running where and everything. And for another thing, like we can do for, let's say, ARM64. Yeah, it's running. And the taint, you can see, is already, yeah. So this is really cool. You can see everything in one glance. If you're like managing multiple clusters, and if you're managing multiple node pools, node classes, I think this is really amazing. And kudos to the headlamp team that who built this feature. It's amazing. Yeah, let's go back to some documentation. Let me make it a bit bigger. Cool. So don't worry, it's in their documentation they have mentioned everything what I have done. Even my demo, I use this documentation to create, and how you can create the node classes, and especially from tags, how you can mention everything. And same time, for the node pools, you can check everything on the documentation, how to create the node pool, this is your shopping list, and what are the labels are available to do, and what are the labels are not supposed to be used, and it's not supported yet. And you can create a cluster without the built-in node pools. I created with built-in node pools to show the demo. And the disruption, which we talk about the disruption, right? So it supports the Carpenter native disruption. So here the disruption examples. If I go scroll down, I will make sure to break in the right place. Where is the disruption? Go here. So some examples here, how the disruption can happen. Here, 20% disruption into your drifted. Then after that, 5 nodes, 0 nodes at this time, duration 10 minutes daily. So if it's starting the day, it will go through this flow. If you have multiple disruption policies, it will go through this. Disruption budget, it will go through that. So this from the Carpenter documentation, and same time, you have this amazing documentation from AWS as well. Cool. And yes, go back to the slides again. If you scan this QR code, it will take you to this GitHub repo. To be honest, I wrote this README using Hero. I haven't gone through each and every spelling check or anything, so please apologize if anything, because I just created today morning. I thought initially I thought not to share something like a URL, but then realized, okay, it's good to share this so people can just install EKS Auto Mode cluster and just they can play around with this, right? So key takeaway, EKS Auto Mode is the managed Carpenter cluster. Like AWS manage your Carpenter workload, Carpenter controllers, and you can manage the workloads. Not only that, like other add-ons behind the scene, VPC CNI, kube proxy, those things are coming in here, but we are not talking about this today. We are talking about mainly the nodes, and node classes are like how the subnet role tags, and node pools are like what the workload, the taints, the instance type you want, and it's a disport, and the disruptions, and use taint and toleration to who schedule where. And the last but not least, I'm heavily supporting the GitOps driven infrastructure. Like if you're familiar with Argo CD, you can use your Argo CD, create app set, and deploy these values via Argo CD as well. So yeah, that's all about it. Any questions? Before that, let me have some water.
Okay. Hi, Zach. It was amazing. So I learned a bit or two. So my next course of action would be to go ahead and implement. And thanks for naming all the clusters and stuff on my name. It was cool. Thanks for that. So so I'll keep you. So there's no much questions. So I think once the recording is out, people will be going through it and they might post questions. So we will come back to this video and we'll keep answering and so on. So we have all the resources available in the chat, and we will also drop all the resources presentations in our group chat as well in our WhatsApp. so you can come back and refer to it. And most importantly, so the key aspect of the builder skill sprint is that we are going to learn, and we are going to also go ahead and go and apply whatever we learned so far. So stay tuned for this coming week. You'll be receiving the hands-on tasks which you can complete at your own pace and submit. And you can submit to our Creators Club. If you're not aware of it, Creators Club is one of initiatives of User Group Madurai, where we track every single contributions that you make to AWS community. So whether be it part of our initiatives, or whether you're writing a blog or making a open source contribution, just drop a note to it, and we will keep rewarding you with user group points. We have one question here from Yogesh. It's so how does EKS Auto Mode decide which custom node class to use when multiple modes are eligible for a workload? And is there any prioritization logic that comes into it?
Is there any priority logic can influence it? So as I mentioned, so his question is, let me read it again. Custom node, which custom node class to use when multiple node pools are eligible for workload? I think I'll rephrase the question. So he's asking, if you have custom node classes to multiple node pools eligible for workload, is there a prioritization for your workload? So let me go back. If you can share my screen again.
Yeah.
I think it's better sharing and showing that, right? If you hide that question banner. Thank you. Cool, yes. So in this demo, we used everything like for the deployment, we had, let's say, for the workload. So we are using toleration for all the workload, right? So we didn't use anything without a toleration. So let's say if your workload is coming without a toleration or label and the node selector, it will go to the by default one, which means we have here the default general purpose, because this general purpose is, if I go here, there's no any. I will go through this one. Is more easy to show. Okay, get node pool. Sorry. Node pool. I'll go for the general purpose. Taint. So you can see there's no any taint in this node pool, which means if you deploy, let's say Nginx pod or any pod, it will basically by default it pick up the default one, because it's not tainted for any specific workloads. That is the class. I mean that will go to the first. So let's say I am deploying something like in this situation something a node class with a default workload here, a custom default. So it will check the priority first, like, okay, if the tolerations are available, it will try to tolerate with that tainted node here. If it's not there, it will by default, it will go to the default one because it can't find it. So it will go and try to deploy and it will say try to deploy. But let's say your workload is requiring some specific architectural or specific resources. Let's say it's a massive chunky size workload which cannot be done by satisfied by the node pools, then it will fail to schedule, because scheduler is the one who picking up, okay, which one to go first. So if you wrap it up, it will go and check if there are any specific requirement for that workload, like any tolerations. No, it will go to the default one, because the default one, it's always available. If you create with the default node class and node pool, this is the one it will take, because currently you can see it's empty. It doesn't have any node claims or nodes, because in our demo we had all the resources we used specifically tolerating that taints, like this node class, so this node pool can we take on specific these workloads? It's a good question. I should have apologize. I should have created another dummy workload with any tolerations. Then you should see this one deploy into that notebook. Sorry about that. Does it make sense? So happy to have a chat after this. Cool. And happy to chat always about Kubernetes and EKS Auto Mode. Feel free to send me a message on LinkedIn. We can have a huddle or meet. I think back to you, Vivek.
Yeah.
Great. And thanks for the question, Yogesh. And feel free to reach out to Zach if you want to have more conversations around the same. And with that being said, we are nearing the conclusion of today's session. And thank you, Zach, so much for hopping in and delivering the stock for us. It's really great. And it's always nice to have to learn something new. And it's Saturday morning for us, and people have taken a bit of time off their weekend to learn something new. And thanks for everyone here for that. With that, over to you, Lokesh.
Yeah. Thank you, Jack, for a deep dive into AKS Auto Mode and how Kubernetes can just use Docker to transform the operations. It was an incredible walkthrough. We can just able to get the things how to simplify the scaling and reduce the cost. And with that, today we'll be happy to wrap up the today's AWS builds skill sprint session. Containers month. Huge thanks to Abhishek and Jack for sharing the expertise and insights in the today's session. Further, that I like to share one more thing on the hands-on challenge, which has been going on of the last month serverless challenge. Let me share the screen.
I think the last month is network, I guess, networking month.
Yeah.
Okay, cool. So, yeah.
Feel free to scan and submit your hands-on challenge. It will be open 5 more days. Like you can until the next challenge opens up. Don't forget to scan and submit. You can just take it quick screenshot of it, and also the challenge will be like available on record session also. You can just go and verify.
Yes, we already have had a couple of submissions for the hands-on challenge, so feel free to drop more submissions, and that's a good chance for you to rake up your user group Madurai points. And with the user group Madurai points, you can redeem amazing stacks. And truth be told, the most active person in this user group and with the most number of points would be able to get 50% off on AWS certification vouchers. So keep a eye on the leaderboard that we have. So that's where you can compete for learning and you can rake up some amazing swags as well. So with that being said, Lokesh, so what we have for next?
Yeah. So today, it was a great interest today. We just went to like lots of large content based on the containers. Thank you once again for everyone, like every participants and the speakers who came forward today, even on Saturday morning. We will just see you back on next sprint. Thank you.
Yeah, it's Saturday night for Zach, but still, yeah, thanks for that. Great. Thank you so much and have a great weekend, everyone. Great.
Bye, everyone.